Whenever I tell someone that I work in statistics, a not long time will pass before they ask for advice on how many samples to draw a specific conclusion. It might be like how many runs in a designed experiment, how many samples to get above a specification line and prove that we're okay, or to prove a difference in two groups. And it's not because it's a very complicated question, but it is, however, very situational. And it also depends on a lot of different things. It will depend on their confidence interval, their signal to noise ratio, the amount of degrees of freedom we have, alpha and beta risks. And it's not because we need to understand all of these concepts in depth, but they all somehow affect this question. So I want to break all those concepts down in a series of videos, this being the first. So why is sampling such a hot topic to begin with? And well, that is, there's a term in statistics that we call population. And the population is, let's say you want to draw a conclusion on some humans, and the population would then be all humans that ever lived. Or you want to draw a conclusion on some device you're making, the population would be all the devices you've ever created on that specific type. And since it's not feasible to test all of them, or it would definitely be very time consuming, we just want to take a small portion of the population out, and we call that our sample. Within our populations, there are some values that we call true. And they could be the true mean, depicted by the Greek letter mu, or the true standard deviation. And we want to know those values. But we will never know the true values, so we take samples of them to try and understand the true values, and that will then be called R mean, which would be an X bar, or S for the sample standard deviation. And that's the difference between these two. And since we know that these values are not true, we want to have them within a certain band that tells us, okay, this mean is not the true mean, but it is a good estimation, and the true mean would be somewhere within this band, and we call this the confidence interval. The confidence interval is where we believe our mean is the middle point, and the band is where we are somewhat certain that the true mean will be. So every time we do sampling, it's very important to differentiate between the estimate and the band in which we believe the true mean is within. And I had to break it down to you that the band, or the confidence interval, is much more interesting than your estimate. So you can't release anything on the estimate. We need to understand the confidence interval wherein the true estimate lies. The good news is that even though we will probably never know the population mean or the population standard deviation, we can, with a relatively little sample, make very good estimates. That's it for this video. I just wanted to get the lay of the land. Next video is going to be why confidence intervals are so important to understand when we're talking about sampling. I don't know how long this journey will be to understand how many samples, but I am happy to be on it with you. So stay tuned and let's see where it goes. Thanks for watching.